Before introducing tab-based navigation, we should clarify when a stateful widget is required and when it's not. It's tempting to assume that a text field always needs a stateful widget because we need somewhere to store what the user types. In the previous example, we used a stateless widget, and that's correct. There's no contradiction. A stateful widget could have been used, but a stateless one is sufficient because none of the three usual conditions applies. The selection screen doesn't need to rebuild its UI. Once the user enters a name, the flow immediately returns to the previous screen. The widget doesn't keep the name, it simply passes it back. And the UI doesn't depend on changing values, since nothing is re-rendered after input. When none of these needs exist, a stateless widget is enough and simpler. After discussing stack-based navigation and understanding when we really need stateful widgets, we can now focus on the last navigation patterns. Tab-based navigation exploits a sequence, a set of tabs that can be selected and activated one after the other. As already mentioned, this approach is useful when we think of different parts of our app that can be used independently. The presentation is mainly based on a navigation bar, which was introduced in version 3 of Material Design. The first part of the app is always the same, so there's no need to comment again on the main function and the use of run app. What I want to emphasize here is the idea of having a more compact organization where run app takes a Material App widget as parameter, which defines the home screen. Home screen must be stateful because we need to keep track of which section of the app is currently being used at a given moment. Home screen state is the usual state manager for a stateful widget that defines a state element called selected index. This variable represents the section of the app we are currently working on. Initially, it is set to 0. We also define a list of widgets called screens, where we include the initial screens of the different sections of the app. In this example, we have 3 elements, each consisting of a center widget that contains a text widget. The only difference between them is the label: home screen, search screen, and profile screen. The interesting part of the example is the usual build method, where we create another scaffold. Its body is exactly the screen selected by using selected index. Then we use the bottom navigation bar, which is a parameter of the scaffold that we have not used before, and is defined by a navigation bar. The navigation bar also has a selected index parameter, which is initialized using the variable selected index. We also define onDestinationSelected, which specifies what we want to do when a given destination is selected. It's a function that takes an index as parameter. Inside the setState, we update the state element because we want the GUI to rebuild. Since setState triggers the build method, we simply change the current value of selected index using the index parameter. The last part of the bottom navigation bar is the destinations, which represent the different items in the bottom bar. These are created using a list, indicated by square brackets, of navigation destination objects. In this case, I'm focusing on only one navigation destination, while the other 2 are omitted because the code would be the same and also due to the limited space on the slide. Each navigation destination uses 3 parameters: icon, which defines the icon we want to display, selected icon, which defines the icon shown when the destination is selected, and finally label, which is the text we want to display. We can now conclude the presentation of the different navigation options by introducing the last pattern, which is called drawer-based navigation. As already mentioned, a drawer is simply a main menu that can be opened either by clicking the small icon on the left-hand side of the upper bar, or, as the name suggests, by swiping from the left side of the screen towards the right, as we were opening a drawer. In this case, the drawer acts as the main index of the application, since it contains all the different sections that we want to highlight. It's similar to organizing the application as a list of independent parts that the user can access. In this example, the organization is similar to the previous one. We have a title, called Menu, and 3 different sections that can be selected by simply clicking on the corresponding entries in the menu. The first part of the code is very similar to what we have already seen before. We have the main function, which calls runApp, where we create a material app that defines the home screen. The home screen is stateful for the same reason as before. We need to keep track of which part of the application we are currently working on. The home screen state acts as the usual state manager. Once again, we define a state element, an integer called selectedIndex, whose initial value is 0. Similar to the previous example, we also define a list of widgets called screens. This list represents the entry points of the different parts of the application, or in other words, the sections that we want to include in the menu. The names are similar to the ones we used before, such as home screen, profile screen, and settings. In this case, we also apply a bit of styling to the text. If we move to the build method, once again, we create a scaffold. We also define the usual app bar, so there is no need to comment further on that. However, we now use another attribute of the scaffold constructor, which is drawer. The drawer can be part of the scaffold, or if we don't initialize it, it simply remains null. In this case, the drawer is initialized using a navigation drawer. The first parameter is selectedIndex, which we initialize using the state variable. Then we define something similar to what we had before. OnDestinationSelected is a function that takes a parameter called index and updates the value of the selected index using setState, because we want the GUI to rebuild through the build method. We also call navigatorPop. This is necessary because the menu is implemented as a drawer, which behaves like a temporary screen. Therefore, we need to navigate back in order to close the drawer and move to the actual screen selected by the user. Another parameter of the drawer is the set of children. In this case, we have 2 elements. The first one is a padding widget, which is used to display the menu title. The padding parameter uses edgeIntSets, which defines the size of the border. Using the edgeIntSets from LTRB constructor means left, top, right, and button. The values 28, 16, 16, and 10 define the spacing on the 4 sides. The child of the padding widget is simply the text menu, with a bit of styling, font size 20, and bold font weight. Similar to what we saw before, we then define the navigator drawer destination elements. We should have as many destinations as the entries we want in the menu. In our example, there should be 3, but here only 1 is shown for simplicity. Each destination defines an icon, a selected icon, and a label. The icon is displayed when the destination appears in the menu. The selected icon is used when the destination is selected, and the label specifies the name of the destination. Finally, the last part of the scaffold is the body. This works exactly as before. We display the current screen by selecting the appropriate widget from the screen's list using the state variable selected index. After the different navigation patterns and options, we can now move to state management.